Hello, we're going to look at an example of decibels. The range of intensity of sound that the human ear can hear is 1 trillion. That is a huge range. And so a logarithmic scale is used to convert those intensities into decibels. Because the logarithmic scale condenses large numbers into manageable numbers, this gives us numbers in decibels that are very easy to work with. So we have a formula for decibels, that a decibel is 10 times the log of I, which is the intensity, over 10 to the negative 12. And we're asked to figure out the decibel level of the following sounds. So we'll start with the threshold of hearing. And we have an intensity here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So let's go to our calculator. We're going to be typing this formula to figure out the decibel level. So here we are at our calculator, and we're going to be typing. So we have 10 times the log, and inside our parentheses we have the intensity, which was point. We had 11 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, and then we had a 1 divided by 10 to the negative 12 power. And let me back up there, delete, get out of my exponent spot and my parentheses, enter. All that work, and we get 0. So what we have is that when we have this intensity level, our decibels is at 0, and that is the threshold of hearing. So we can write in here decibel level 0. Next, we're going to do this one. So this time we have 1, 2, 3, 4, 5 zeros, and we'll type it in the same formula to find our decibel level. So our formula is 10 log, then we have point, 1, 2, 3, 4, 5 zeros, 3, 2, divided by 10 to the negative 12. And this time we have a decibel level rounded off of 65. So our decibel level here, 65. And we have one more. This one's much easier to type. We have the threshold of pain when the intensity is 100. So let's try that on our calculator. So this time we'll type 10 log 100 divided by 10 to the negative 12. And we get a decibel level of 140. So that completes our chart. Our next question says that my dishwasher operates at 53 decibels. What is the intensity of the sound from this appliance? So first off, when they were selling me a dishwasher, they all had this decibel level listed, and that is because we want a dishwasher that operates quieter than normal conversation, and we see at the decibel level of 53, normal conversation at 65, so this dishwasher is quieter than normal conversation. But we want to use the formula and solve this out, see if we can figure out the intensity of the sound of the dishwasher. So because we know the decibel level, we're going to be putting that into our formula right here. So for this problem, we have 53 is equal to 10 log parenthesis 1 I over 10 to the negative 12. So in order to solve, the first thing I'm going to do is divide both sides by 10, because I see this is multiplied, and that's easy to do. It's the inverse. So divide by 10 on both sides, so I get 5.3 is equal to the log of I over 10 to the negative 12. Now, I want to do what is the inverse of logarithm. And logarithms are the inverse of exponentials. So, in previous problems, we had used a logarithm to figure out the exponent. Here, we want to use a base to figure this out. So we want to use a base of 10 because this is a common log. So I'm going to make this whole thing into the exponent base 10. If I do that on this side of the equation, I have to do the same thing over here, so I put a base of 10. These are true inverses, so they cancel out. So I'm left with 10 with an exponent of 5.3 is equal to I divided by 10 to the negative 12. So this is using the inverse property right here to get rid of the logarithm, doing it to both sides using a base of 10, and you can see that as I rewrote it, 10 is the base, 5.3 is the exponent. Now, to get I by itself, I'll multiply on both sides times 10 to the negative 12 power. These guys cancel. Over here, I'm also wanting to multiply by 10 to the negative 12 power. And so I will find the intensity of sound equals, and I have to go to a calculator to do this. So I have 10 to the negative 12 power times 10 to the 5.3 power. All right, so it gives me a number that is in scientific notation, and I know that because of the little e out here. And so I would round this number off to 2, or 2.0, because of the 9 and the 5. And then this negative 7 means that it is a very small decimal. I need to move my decimal point 7 places. So I would move it 1 and then 6 more. So that means I'm going to have 6 zeros and then a 2. So going back here to write my answer, I had 1.995 times 10 to the negative 7th power. This means I need to move my decimal 7 places. So 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6 zeros. So my intensity is equal to 0.0000002. You can see why the logarithmic scale is used, because reporting that the dishwasher has a sound level of 53 decibels is much more manageable than saying the sound intensity of this is 0.0000002. We knew that 53 decibels was quieter than a normal conversation, and when we see this decimal, it truly is smaller than this intensity. But the logarithmic scale gives us numbers that are very manageable. In solving this problem, when we were given intensity levels, we just used our calculator to evaluate this formula. When we were given the decibel level, we had to go through the algebra. Key in doing that algebra is right here, where we use the inverse property, which is to use a base of 10 to cancel the common log.